In our final example, we're going to write some code that does different types of mortgage calculations. Our goal isn't so much to teach you about mortgages, but to show you how to structure the code, and in particular, to try to take advantage of earlier code that we write. So for example, after we've written the code that supports the calculations for a fixed rate mortgage, the code that does the calculations for a fixed rate mortgage with upfront points is very similar, and we want to build on the code that we wrote. Classes are a convenient way to tackle many programming problems. For example, let's do a mortgage calculation. Suppose I want to borrow $200,000 from the bank and pay it back over 30 years. The bank has given me three options: a 30-year fixed rate mortgage of 7% per year, or they will let me pay some amount of upfront money called points, in this case $7,000, in which case they'll give me a 30-year fixed rate mortgage of 5%. Or they'll let me, for 4 years, they'll let me pay a low interest rate, but then the rate will almost double for the remaining 26 years of the mortgage. What I'd like to do is figure out what's the best deal for me. Let's write a program to tackle that idea. Here's our program. We went out to the web to find the formula we can use to compute the monthly payment for a mortgage of size loan at a monthly rate of R for m months. So we embedded that in a little formula that we'll use below. We created a base class that we're going to use for all of our mortgages. What the base class does is sort of support the basic operation of a mortgage, and then the details of the exact interest rates and payments and things like that we'll describe it for each mortgage separately. So the mortgage base class remembers the principal amount of the loan, and it computes the monthly percentage rate from the annual interest rate that was passed in. It remembers the total number of months for the loan. It keeps a list of all the payments that have been made, and initially nothing has been made. The amount that's owed is computed each month, so we start off owing the entire amount of the loan. We pre-compute the monthly payment using the formula from above, and we define a legend, which we'll be using down here when the mortgage is asked to print itself off, and we'll define that instance variable now in each of the particular subclasses that we'll define. The mortgage supports the basic operation of making a monthly payment. So what we do is we take the pre-computed monthly payment and we add it to the end of the list of payments that we've made. We then have to compute the amount of the payment which is going towards reducing the principal amount of the loan. So we take the principal amount that's currently outstanding and multiply it by the current monthly interest rate. That tells us how much of our payment is owed in interest. The remainder of that payment then is used to reduce the outstanding principal. So at the end of each month, after we've made our payment, we can compute the new amount owed by taking the old amount owed and subtracting from it the reduction in principal from our payment. Finally, we support the notion of figuring out what the mortgage has cost us through all the currently made monthly payments by summing up all the elements, all the payments that we've made to date. Okay, so here are the three types of mortgages we want to do. One is a fixed mortgage, which is really exactly what the mortgage base class implements. So we simply make a subclass of the mortgage base class and go off and initialize it with the parameters of the fixed rate loan and provide a legend that describes the loan. A fixed with points, so that's where we did an upfront payment, really is just like fixed. So in fact, we made it a subclass of the fixed rate mortgage. And the only distinction is that we have an initial payment up front that is some percentage of the loan. In this case, we pass in the number of points, which tells you, well, in this case, 3.5, which we use to calculate the initial payment. And then after that, the mortgage works just as before, except hopefully the interest rate here will be lower. And we have a different legend here, which starts off with whatever value was defined for the legend by the fixed rate superclass, and then we add to that an annotation indicating the number of upfront points. And finally, we have a two-rate mortgage, where the mortgage changes rates from the teaser rate after a certain number of months. It will actually then increase to a larger rate. So what we do is remember all the different parameters. We have 2 mortgage rates in the initial term of the cheaper rate. We have a more complicated legend explaining the mortgage name. And then finally we look at the make payment thing. And so what we've done is we've override the make payment method of the mortgage base class because we have a more complicated thing we need to do. So initially we're going to go off and set up the mortgage to be being paid off at the teaser rate as if we had gotten a 5% loan. So we'll have a low monthly payment because the teaser rate is lower than the final long-term rate. So once we've paid that number of monthly payment, the number of teaser months, in this case 48, what we're going to do is to say, aha, now we're going to up the rate to this new higher percentage rate and we'll recalculate the payment based on the amount of the outstanding principal that's still left. And at that point, once we've made that adjustment, which we do at the 49th month, we go off and now just make our use the standard payment algorithm. It's just that the payment algorithm works with different parameters from the 49th month and beyond. So now we're in a position to actually do some comparisons. And again, we've gone off and embedded our little mortgage reporting thing inside a function so that we can actually try many different experiments with the different options. So what we do is we create some alternative mortgages. We create a fixed rate mortgage, the fixed rate with points, and the 2-rate mortgage based on the parameters that get passed in. And finally, we run the experiment where we're going to make now 30 years worth of payments on a monthly basis. And for each of the mortgages in our little list of sample mortgages, so the fixed rate with points, and the 2-rate mortgage, we're going to make a monthly payment. In this case, a total of 30 years of payments on each of the mortgages. And finally, when we're done, we're going to report back the results. So the advantage of instead of filling a couple napkins full of calculations, by putting it into a program, we'll get to run many experiments in a row. Alrighty, so this is the experiment that we want to run. We actually have the description of the problem we were facing. So I'm going to come over here and paste that in and then ask Python to print out the answers. And we can see that if we have a fixed rate mortgage, we pay a total of about $479,000. Fixed rate with the upfront points was about a little over $390,000. And then the 2-rate mortgage, or the adjustable rate mortgage, you can see here the total is $551,000. So the best deal by almost $100,000 is the fixed rate with points. Well, we're not so much trying to teach you about mortgages. Our real goal in going through this example was to sort of point out that we can do a lot of code reuse here in describing the operation of the different mortgages by starting with a mortgage base class, which describes the operation of a fixed rate mortgage, and then elaborating on that either with an upfront payment and hopefully a lower interest rate, or a fixed rate mortgage where the rate changes some number of months into the thing. And so we've basically encapsulated the distinctions of our different mortgages from a regular base fixed rate mortgage in each of our different classes.